Thank you all for joining us today for what I can promise will be one of the most mind-blowing conversations you're going to hear today for sure, and probably definitely for quite some time in the breast cancer space. So I'm really excited to talk to Dr. Connie Lehman, who's here today, about what we're doing to reverse this trend, how we are going to approach risk assessment in the age of AI. And I can't stop smiling because this is one of my most favorite conversations to have. Um, the fact is that patients like me, I was diagnosed at the age of 36, are becoming increasingly common. And we can't just sit here waiting to treat them. Every patient, like myself, I found my own lump. 80% of patients under the age of 40 find their own lumps. And we need to do better. We need to do better by people so that they can understand their risk and take action when they need to. So, Dr. Connie Lehman, why don't I give you a second first to introduce yourself?
So, Sadia, first of all, thank you so much for having me. I'm so glad so many folks have joined us. I'm looking forward to our conversation. I was always in academic medicine. I was so grateful early on to become part of the BCRF family, an environment where really people that think outside the box and think, how can we do things better? How can we innovate differently? Are really not just supported, but celebrated. And that culture within the BCRF family, across its supporters, across the all the people that keep the BCRF running, and the investigators, that culture doesn't just happen. It's really with the incredible vision of the brilliant, brilliant people that started it and fostered it. And so I was always in academic medicine, studying better ways as a radiologist that I could leverage the power of the images of the human body to improve the outcomes of our collective patients. And when I started working many years ago in computer aided detection and diagnosis, it was more having these aha moments of, we're not really leveraging the full power of these computers. We're trying to have them just help the human be a little bit more consistent. And then with the revolution of AI, having the good fortune to meet Regina Barzilay at MIT, the large database I developed at Mass General, and bringing our two groups together to develop these breast cancer risk models based on the image alone, it really opened the world to a new pathway. Then making the decision to found the company Clarity opened yet another pathway. So the research and the science is so amazing. But if we don't have a commercial product, if we don't have that pathway for implementation globally, we're not going to have all the women that we want to have an impact on. So that was a new domain for me. And there was BCRF right by my side saying we not only don't question or wonder why you would be distracted by founding a company, but we're going to champion this because we get it. We know that this is the pathway that more women will have access to this technology. So I'm really excited to be here to talk more about what Clarity Breast is, what the domain of AI image-based risk assessment is all about, and what I think we're all going to start to be seeing in late 2025 and into 2026. So the fact that it's actually with us now, I'm sort of pinching myself because it was a vision that's now becoming that reality.
And I think that's what I want to drive home today, which is that we're talking about one of the biggest breakthroughs of our time when it comes to how we are moving mammography from what you just talked about, which is a diagnostic tool. So mammography, which is now using AI to not only improve its capacity to diagnose breast cancers, but now move that into predictive imaging and having it now tell us that yes, you don't have breast cancer right now, but you have a maybe a 60% chance of developing breast cancer in the next 5 years. So we're talking about a really quantifiable, tangible risk assessment in a brand new way. And that's what Clarity Breast really has to offer. And the implications for that are profound. So let's talk about how you see AI-driven predictive imaging going from this reactive care, finding out you've been diagnosed, to proactive care, finding out I might be diagnosed in the next 5 years.
So one of the things I always go back to is those patient experiences where, again and again, my colleagues and I, when we would talk to a patient about her recent breast cancer would have that woman say, this is just impossible. No one in my family has been diagnosed with breast cancer. I'm healthy. I just didn't see this coming at all, nor did my doctor. We barely even talked about, risk of breast cancer. How is this possible? And what we realized was we were so used to that conversation, but it was sort of begging the question, how can we change that? How can we change it so that we don't have so many women saying, this just isn't possible? And then when you look at the research, and as you were saying, for women under 40, 80%, they're not diagnosed by early detection and imaging or other tests that we could do to find them early. It's by a palpable lump in the breast. That's a level of detecting breast cancer that we only see in countries that have no access to mammography and MRI and ultrasound. And so, how can it be that for women in the 30s, we just think that's what they need to just accept? And it's not acceptable. It's unacceptable that we continue to see the fastest growing body of breast cancer diagnoses are in young women. This disease is changing. It took us far too long to say we're going to screen women not starting at 50, but starting at 40. And there are many countries in the world that still wait until 50. That just wasn't acceptable. We had too many women for decades not being supported to be screened in their 40s because of outdated approaches of how we should screen and where cancers occur. But I would suggest that we're in the same place with women in their 30s. We're sort of complacent about it. 85% of women diagnosed have no family history. 80 to 85% are not being identified by current methods we have to tag someone at increased risk until now. And so that's what we want to do. We want to leverage the power of the image, not only in detecting and diagnosing breast cancer before it can be felt, but pushing that even earlier where we can assess the risk, we can predict the future, and then we can intervene not only to detect as early as possible and not wait for that palpable lump, but also to have more effective, more precise, targeted ways of preventing the cancer from developing. And so risk assessment, it's such a key cornerstone to how do we do a better job in early detection and how do we do a better job in preventing cancer from progressing or developing.
Mhm. Okay, you just said some really powerful things that I'd like to go back and again dig a little bit deeper into, which is number one, you mentioned that 85% of patients have no family history and no genetic mutation. So this is the vast majority of breast cancer patients are shocked. They have no idea that they were at risk for breast cancer. And none of the current risk assessment models, so the Tyrer-Cuzick risk assessment, the Gale model, et cetera, really rely heavily on identifying those 15%. So those people that we do know because of their family history, et cetera, are at high risk. But we had no way of finding the 85% of patients who are essentially needles in the haystack, who we can figure out what is it that will drive when will you be diagnosed with breast cancer and will you be diagnosed with breast cancer. So until now, something else you said, which is that until now we could not help those 85% of patients, people like me who were never flagged as high risk. So I want to get into that a little bit because we talked a little bit about the limitations, but what are the limitations of the current models and how does AI help us move to something that is more inclusive for all women?
So I think one thing that we know is that we have different types of breast cancers. Again, thanks to the BCRF, we've made incredible advances in understanding not all breast cancers are the same. Women diagnosed with DCIS are in a very different category of breast cancer patients than those that are diagnosed with triple negative invasive cancers that are very aggressive and fast growing. And so we can start to really have so much data about the different types of cancers and we can put them into different categories to help us understand best how to treat them, how to prevent recurrences, and how to ensure that that woman lives as long and healthy, cancer-free life as possible. So that's one domain. But if we bring it way back, we can also have these big baskets. Here are the cancers that are occurring in women with a known genetic mutation. These are the cancers that we see in those patients with strong family histories. And then we have all these other ones. And it's all these other ones, those 85% of cancers that we start to say, well, these seem to be more what we refer to as sporadic. They just happen. The first person in the family that was diagnosed with breast cancer. And again, no known genetic mutations. And so for these sporadic breast cancers, what is it about that patient that allowed that breast cancer to develop? How can we understand that better? I love the history of medicine. So you go back into the 1700s and they would talk about the seed and the soil, that we focus a lot on the seed of cancer. And we need to pay as much attention to the soil of the body, or in this case, the breast tissue that allows that seed to grow and expand and even metastasize. So, what is it about the soil? And I think in many ways, the mammogram was giving us a picture of that soil, but without AI, we couldn't extract the digital data points of that tissue that were evident in the mammogram. And then another part of medical history that I think is really interesting is in the 1970s, John Wolfe was a radiologist, and he said, I really think the mammograms of my women that in my clinic that have developed breast cancer, they look different than the women who never developed breast cancer. And I don't think it's just density. I think it's more the patterns. And he tried to categorize those patterns. And he wrote in his radiology publication, wouldn't it be great if we had computers that could take this information in and then rank and order the women more likely to develop breast cancer from those less likely. And that was in the 1970s. He just didn't have the computers that he referred to. He didn't have the power of AI. So I think what we're able to do now is to extract these signals from the image. I think they are very, very relevant to the sporadic breast cancers that we see in our practices every day, the majority of breast cancers that we're diagnosing. And I think it's a way for us to open up a whole new field of research in this very large group of patients that we've always been, I won't say complacent, but just sort of saying, we just can't find them all. Or maybe there's more genetic mutations yet to be discovered. Maybe we really need to focus on polygenic risk scores. All of those are true, and that work is really important. But in the meantime, we've discovered something that allows us to identify so many more of these women early and make different interventions. So we finally have something to offer to these women where we used to just throw up our hands and say, I know it's crazy. It makes sense that no one was thinking you might develop breast cancer. That's a common story, and I'm sorry it's your story.
Mhm. Well, it's so, well, thank you. But I want to touch on that a little bit and just to drive home the scale of impact here, because we've talked about the fact that 85% of patients now can benefit from using a platform like Clarity Breast to understand what their risk is over the next 5 years. When we talk about the fact that breast cancer incidence is on the rise, it's rising across all age groups, but breast cancer is rising at double the rate for women under the age of 40. So when we are able to now raise the alarm for certain patients in that age range who are now being diagnosed younger, they can, what you said earlier, benefit from early detection. Because right now, patients under the age of 40 are not able to be diagnosed at stage 0 DCIS, stage 1. Usually it's at later stages. Like myself, I was diagnosed at stage 2 after finding a palpable lump. So we're offering patients not just the ability to be diagnosed earlier, but to take steps to prevent the disease from happening at all. So when it comes to finding out, let's say you are using the platform, you find out that you're at higher risk. What now? What are the interventions that we're looking at for patients that are identified as high risk?
Well, Sadia, it's a great question. One of the reasons why I'm particularly excited about the rapid impact I think we'll have is that for a very long time, experts in the field, we've all been working on just exactly to answer your question. If you are at increased risk and you're 30, not 40, not 50, what should we do? The NCCN, the American College of Radiology, the American Cancer Society, they've all worked on this with expert panels, and they make recommendations of exactly what those care pathways are if you're at increased risk. So it's very clear, for example, with the NCCN, if you're identified at increased risk and you're, let's give an example of 30 years old, we definitely want you to have early detection imaging programs as part of your healthcare platform. So we want to see you having a mammogram every year. And if you are at high risk, to consider an MRI as well every year. So that's been a standard recommendation for some time now, and a lot of science to back why would you want to do supplemental imaging, something more than just a standard mammogram in these patients at high risk. So that's where we see these types of AI image-based risk scores plugging in. We already have the care pathways. We're now just identifying a really important group of patients who can enter into those care pathways in the absence of a genetic mutation, in the absence of a strong family history, but in the presence of a validated, strong, effective AI image-based risk score that's going to open that door to improve care to more women that, have had that door closed to them in the past.
And it's so interesting. I will say that from my vantage point at BCRF and seeing the sort of we're funding research from across the entire spectrum is the research that's happening right now specifically to intervene and to intercept the disease before it takes root coincides with this ability to now identify those high risk patients, right? So those two things, these bodies of research are happening at the same time, and one is meant to sort of supplement the other. Is that once we find these high risk patients who is qualified and can benefit from vaccines, for example, that are already in clinical trials in healthy patients right now by some of our other investigators, or chemotherapeutics, essentially options that would allow them to prevent the disease that are not as radical, for example, as a double mastectomy. And so they might go in and or implement interventions like cutting out drinking, taking up stopping processed foods. I do want to ask you, you mentioned something about at the age of 30. Can you tell us how you see something like a Clarity breast? At what point in your life do you access this tool? Like, what do you see the future of this use case scenario being?
I would love to see the breast cancer community really embrace and push for uh, different processes for how we screen. I can't stand the idea that we would take another 20 years, because we've been debating about 40 or 50 for that long, that we would take that long to think of a more elegant way to screen our patients under 40. And we've done it for a very small group of women, those with a genetic mutation and strong family history. We can now expand that. And it's not a huge expansion. We can be very, very targeted in those high risk by the AI image-based risk scores, those high risk to add them in. And that's really what we're poised to do. So I would see that we have women at age 30 having a baseline mammogram, having a discussion about their risk, making sure that none of those women had an unidentified family history or genetic mutation that had just slipped through the cracks in their normal, lifespan. Often when women are in their late 20s, the focus is so much on childbearing that people aren't paying attention to the rest of their health. And so we would have an opportunity at that age to make sure that we really have a good understanding of their genetic, of their family history, risk factors, and based on that image of their AI image-based risk. Then if they're absolutely average risk, we could check again at 35, check again at 40, and then they enter into a more average risk, normal screening program in their 40s, 50s, and 60s. But we're going to identify women that shouldn't wait until 40, or certainly in countries that start at 50, shouldn't wait until 50. Now, why would some people say, oh, that's crazy, you can't have a baseline mammogram at 30? I remind them that, it wasn't that long ago that the American Cancer Society actually told all women you need a baseline mammogram at 35. They wanted that baseline mammogram because they knew that women were being diagnosed in the 30s, and this was back in 1970. And so given that we then sort of had that fall to the wayside, I think because we were just trying so hard to get 40 being the age to start rather than 50, I think we need to come back and reconsider that concept of a baseline. And also, I just want to remind folks that, the challenge we had in moving the country from 50 to 40 was because many women in their 40s are very low risk for breast cancer. Not all, but many. And the other side was saying there will be so many false positives, there will be sort of unnecessary biopsies and overtesting. And so they had to really balance those potential harms with the potential benefits. We can be so much more precise now about that. So we're not saying screen all women every year in their 30s at all. We're saying let's have a baseline. Let's identify that small percentage that need to join those with the genetic mutations and the strong family histories. And let's allow the others to feel more comfortable and confident that they are at a lower risk and can be checked again at 35 and then 40 and then forward.
Well, I think it's number one. First, it's funny. I should add that if you have questions, please submit questions in the queue. There is a Q&A function here. We did have this exact question that you answered. So thanks, Athena. I saw that question that as you were asking, Dr. Lehman answered on starting those baselines at 30, which is again another revolutionary statement we're hearing here, which is that the idea that we arm patients and use a baseline as a preventative tool. So that it's a tool that's being used to inform us on what actions we may or may not need to take. And one thing I've heard you talk about is sort of how dynamic this can be, and using the baseline, and then if you're identified as high risk, like and seeing, let's implement these interventions. Are they working or not? And that clarity can give you that answer. Can you talk a little bit about that, what we mean when we say dynamic?
I'm so glad you brought this up because that was definitely a big aha moment when people would say, well, you have this 5-year risk score, so I guess you would have it. And just like you have your genetic testing, then you would know what your image-based risk is, and then you're set. But when we started to look at our data, and thank goodness we have such huge databases with sequential mammograms, we had the opportunity to, with the BCRF support, to study how these AI risk scores change over time. Because I could, do genetic testing on a patient that has a BRCA mutation. I'm going to do that once and I'm going to know the answer to that. They weren't positive for the genetic mutation, and now 5 years later they are positive. But we wondered, with this AI image-based risk score, might it change? Now, we had good reason to hypothesize it would, because many folks, also BCRF investigators in this family, such as Jack Kusek, had way back said, I think the breast tissue changes with the intervention. So his hypothesis that when women go on a risk reduction medication like a tamoxifen, that the mammogram would change. And he documented that change and showed that change in breast density. But again, I always come back to breast density is important, but it's a tiny, tiny extraction of information from the mammogram. And now with the computer vision, the strength of AI, we can extract so much more predictive data. So if we basically take Jack's hypothesis, and instead of using density, if we use the AI image-based risk score, I think it's going to be even more powerful to really, really both develop better medications, assess the right dosing for every woman, and being so much more targeted in the way these should be administered to the individual patient. And I think if I were a woman and I was going on a risk reduction medication and it was making me feel lousy, and I was young and I was thrown into early menopause, and I was going like, I don't even know if this is helping me. I don't know if it's helping me, but if I could see that my risk score had been high and came down and stayed down, I think it would be would be like if I went on a statin and I saw a dramatic impact on my cholesterol level. I'd be like, okay, I don't love taking the statin, but I'm going to hang in there because it makes me feel really good to see my cholesterol levels at the level that my doctor and I want them to be. So I think the piece where we're seeing these are dynamic, they are not static. It's not just one and done, but we can continue to measure them over time. So we'll be presenting our latest science at a meeting, and this research was funded by the BCRF, where we found that 4, 5, and 6 years before a woman develops breast cancer, her AI image-based risk score starts to creep up in a very significantly different way than women that never develop breast cancer. So it's a little bit like PSA. It's not just your score, but how does your score this year compare to your score last year or 2 years ago? And we'll track that. I think it's going to help a lot of women make decisions also, not only in the interventions they're taking to reduce their risk, but also there are women who know that they're at high risk. They have important decisions to make. Maybe they want to finish their family and having children, and then have, for example, if they have a genetic mutation, a bilateral mastectomy, but maybe they want to wait. And this allows us to see if the program that they're under is keeping their risk low or not, and just be another element that they can put into their decision making. So I see a lot of different areas where we can hopefully leverage this data and leverage this information to guide better choices, more precise choices, more targeted choices for women, particularly because of the dynamic nature of this risk score.
Well, I mean, it's so fascinating to me that not only are you able to get that initial risk assessment, but then to go back and see, did my intervention do anything? Is it working? And I mean, to me, that's mind blowing. And I think you hit the nail on the head. It's giving you that validation that the things that you're doing are working, or it's not working. You need to change tactics. So I think that also just the power of giving patients that information is, the implications are um, the ripple effect of that go on and on.
And that's another way that it could be interesting. So if a woman is debating, like, do I really want to stay on tamoxifen or raloxifene or whatever medication they're taking, we can also go back and extract a prior mammogram before they started that risk reduction, see what the score was then, see what it was after. And these are the kinds of studies we want to do. Like how well will that work? Could you, because the hypothesis would be, you could all we love these risk reduction medications. In many studies, some of these medications are going to drop the development of cancer in half. That's amazing. But it also means that some women doing everything they possibly can are still having these breakthrough cancer diagnoses. And so, can we identify those women? Can we identify those? How much would this risk score help us separate out the ones very unlikely to develop cancer, given their current regimen that they're on, from the ones that, even on those risk reduction strategies, still are at risk of having a breakthrough cancer diagnosis? So I think these are the kinds of studies that not only we want to do, but the consortium of members of the BCRF are really in a good position and poised to do together.
Mhm. So, one thing I want to ask, sir, is where are we now with Clarity Breast? So, I know it received FDA approval earlier this summer, de novo, which of course is a big, big deal because it means it was the first tool, the first platform of its kind to receive FDA approval and to seek FDA approval. So that was a really big deal. Where are we from today to accessing this platform?
So that whole process of the differences in a research model and the different ways to like distribute research models from commercial products I learned a lot. It was really exciting. And I do have to do a total shout out and kudos to the FDA. They're under a lot of stress and pressure these days, as we all are. And the committee that we had really were so thoughtful. It took a lot of time because what we were doing, as you said, de novo authorization means it hasn't been done before. So there was no predicate, there was no recipe we could follow, there were no standards that had been developed. And they had to wrap their brains around and work with us together in a very, co-creative, collaborative way. Well, what does it mean that we have an AI risk score that is not a task that the radiologist or a human can do? Because everything else we've done at the FDA has been this is an AI tool that can help the radiologist identify a cancer and detect or diagnose a cancer that's on the mammogram. So it might be something that a human would have missed, but with the AI computer's help, it'll flag it, it'll mark it, it'll say, hey, I think this has a 30% chance of being a cancer. Maybe you should look at this more carefully. And so those were all assistants and aids to the radiologist, but the radiologist had the final call. So it was really the human. It took some time for, total agreement that this just isn't something. I mean, I'm a breast imaging expert. It's all I've done my entire career. There is zero chance I can look at a mammogram and tell a woman what her future risk of breast cancer is at all. Never mind the precision of this AI risk score, which has been calibrated so that if you're in a group of women that are told your risk is 3% in the next 5 years, and that's double what a woman average risk would have, that group of women is going to have there's going to be a 3% rate of cancer. So it's highly calibrated. And humans just can't do that. So they helped us with working through that and having the appropriate labeling on how that would be used. The bar for the external validation of the performance of this was incredibly high. Over 75,000 screening mammograms from 5 geographically diverse US centers with very strong 5-year outcomes for cancers that were diagnosed. So this was sort of at a level that we haven't seen before with the FDA. So we did all of that. We got the authorization. That was the last day of May this year. And then that allowed us as a company to talk to others about the commercial offering we could then make. And we couldn't have those conversations before we had the FDA authorization. So we're delighted that we have 3 very strong partners that are excited to implement. We're doing the very rapid work to implement at those sites so women can have access. We're a very, very small company. We're about 15 people, but we are working as fast as we can to really realize the vision and the goal of global access.
So we're talking imminently, right? We're not talking about 5 years from now or 3 years from. We're talking about patients that are going to begin accessing Clarity Breast by submitting their mammogram in the next few months.
Our goal has been the last quarter of 2025. So I'm really saying I want to see, the first women being able to have access to this in 2025. 2026 will be a huge year. That's where we're really going to be, on a very once we basically set up the process for implementing this in different systems to really have that just exponential growth in 2026. But we're well on track for having the access for our first patients in 2025.
So we also received a question, which of course we knew we were going to get, which is, once patients access this, will it be covered by health insurance? So will Clarity Breast, and if it's not available, are there resources will there be resources or planned resources for patients who are in low resource areas potentially to be able to access this?
One piece that I felt very fortunate is that the VC group that provided me the Series A and a huge portion of our Series B to be effective as a company, as well as our CEO, Jeff Luber, from the very beginning have been 100% engaged in the vision and mission that I was bringing from my academic background into the company. I had met with a lot of people where the emphasis was really on how can we make money on this, and that was not my experience with Sante Health or Jeff Luber. What they were saying is, how do we have this impact? And so we want women to have access to this. We are pushing very hard. This is a strong tool. It brings such value to women, brings value to reassure women that don't need more intensive interventions, that is a safe pathway. And it brings reassurance to women that we are identifying that are at increased risk, that we have a better pathway for them than before we had that risk information on them. So So it's a very strong tool. It checks all the boxes that our administration is looking for. How do women living in rural communities have access? Most AI products were built in the early days on women from 3 states, California, Massachusetts, and New York. We have, from the beginning, made this a very diverse platform of patients that have contributed data to developing the model, from Texas to Colorado to the middle of the country, California, Georgia, everywhere. So it really has always been built on access and inclusion, and we're going to stay with that. How do we keep that bridge between FDA authorization, clinical implementation, and then payment by Medicare, Medicaid, payment by our insurers? How do we keep that gap as small as possible? By working and pushing very hard and educating folks that are in those decision-making positions of the importance of this, and then pricing it at a level and working with groups to make sure that price is not a barrier. We do have a self-pay model to help bridge this period of time until it's paid for by insurers and by the government. We're pricing it at a point where we really don't believe and want it not to be a significant barrier based on that self-pay. We also have a strategy for centers with Medicaid populations where we can help supplement the cost for those patients as well. So our early adopters, they believe in the same, core values that we have of how can we have all of our patients have access to this, and we're really working creatively together to figure out how to do that. Many of the groups also have very strong supporters that are saying, while we're trying to bridge this gap between the implementation and the payment, let us help you. Let us fill in those gaps and support women where, a price of $199 for a test actually would be a challenge for them. Let us help you with that. How can we work together to make this accessible for all and not only those with the ability to pay?
Gotcha. And so what we're getting at here is that the goal is to make it accessible. That's the bottom line is of what you're saying is while we're working on ensuring that health insurance does cover it, what else and what other tools and resources do we bring together so that patients are able to access Clarity Breast? So, there's also an interesting question here from someone that says, are you using AI to determine recurrence risk post 10 years of diagnosis? So I am curious about that, is that we have been so far talking about patients who have yet to be diagnosed. What about those that have already been diagnosed and they're using Clarity to assess risk?
We were really excited and delighted that we included patients in our studies and in our research that had a history of breast cancer. So personal history of breast cancer did not exclude women from our studies. Many, many studies in screening exclude women with a personal history of breast cancer. They're only looking for patients that are coming in having not had breast cancer before, but those were included both in our model training and in our validation of the model. And so we really see now this is in women that had breast conserving surgery. So
Right.
our model at this time is for women that still have both breasts, even if one had a breast conserving surgery, a lumpectomy, radiation, that's all right, but they still have 2 breasts and they still get a bilateral mammogram. For those women, we do apply our risk score, and we are also excited to do the even, a larger volume studies to show if there are certain types of women that this is particularly helpful in identifying earlier an increased bump, a change in that risk score. I'm still surprised at how variable it is across the country, which of our patients with a history of breast cancer are getting supplemental imaging and which are not. There are many, many women I see across the country where they have a history of breast cancer, it's been treated. We have many women that aren't even routinely coming in for a mammogram after their treatment, or some that come in for their mammogram maybe every year, maybe every 2 years, but they aren't having any supplemental imaging such as MRI. And that doesn't really make sense to me because their risk of a recurrence is higher than many of the rates of a breast cancer diagnosis in other populations where we support screening MRI. So I'd like us to leverage and use this tool to have more women get access to supplemental imaging after their own breast cancer diagnosis, and also more women to understand how is the chemo prevention that I'm on, how is that working? Has my risk come down or am I staying high? Do I just sort of have some stubborn profile in my body that we have to work to figure out what's a better way to reduce my risk?
Mm. I mean, I think that's really interesting because it just occurred to me as this question was being asked, right, how does it work for breast cancer patients as well? So that's very, very interesting. There's another question here about availability internationally. And so will it be available in Canada and what does that rollout look like?
Yeah, so we had to make a decision as a company. Do we start in the US and go global? Do we start globally and then come back to the US? And we made the decision to really focus full force on the FDA authorization. We realized it was going to take a lot of time as a small company because pretty early we realized there's no predicate. We have to have FDA authorization. This is going to take some time, but we really felt like that was the right way to go. Now we brought in a new member of our small but mighty Clarity team, and he has experience in the global markets and is really looking at our fastest and best strategy for the regulatory approval we would need in Canada, in Europe, in Asia, in India, and other parts of the world. So we're very excited on pushing that forward and having that go as quickly as possible. And it's interesting because there's really two elements. It's what are the quality programs that need it to be in place to submit the regulatory package, which countries pretty much accept the clinical validation we've done through the FDA, which want new studies done. So we're looking at that map, but as fast as we can, we do want to, have be a globally accessible product.
Mhm. And there is another question here that I find just as interesting is using, and you talked about the subtypes of breast cancer and being able to predict some of that. What about other rarer subtypes like inflammatory or lobular breast cancer? Does Clarity's risk assessment score predict those as well? And or is it just a risk assessment for breast cancer writ large?
So we can answer that in two different ways. It's sort of our hypothesis and then the studies yet to be done and how excited we are to continue to do those studies. So we started off just saying we're going to include all breast cancers in the model training, but I want to really clarify that we will say that these were breast cancers in a average screening population. So these weren't the patients that were coming in with 4 centimeter palpable masses in their breast, and that was the cancer diagnosed, because we really wanted this to be something we applied to screening mammography programs and the full diversity of women coming in for a screening mammogram, but that would mean without the palpable lump or the cancer that was more advanced. So that is what the model was trained on. How it would then generalize to other types of cancers outside of the cancers we're diagnosed in our screening programs is yet to be seen. But I really feel like the strength of this model is on those that are being identified in our screening programs, because we're trying to do that risk assessment, getting as early as we can. And this is, I thought, the right population to do that in. So we certainly started to say, well, did it learn better how to, because most cancers, and we had mammograms in patients from South America, from Germany, from the US. So the question was, in South America and Germany, they're much more focused on invasive cancers than DCIS. We identify more DCIS in the US because it's just the way we approach screening and reading the mammograms. And so we found that the model performs equally well, whether in our Brazil, our South America, or our Europe or our US populations equally well in invasive cancers and DCIS. And now we're doing the studies about the more aggressive cancers and the less aggressive. So the different histologies is TBD, but certainly at that level of invasive and DCIS, it's equally performant.
Mhm. And there was another question along similar lines as far as it working. And I actually know the answer to this, but I'm still going to ask you anyway, which is, does it work in younger patients as well as is it as reliable in younger patients as it is in older women?
So we will be presenting that science at our Radiologic Society of North America meeting this winter, and we looked at the model performance for women under 40, 40 to 50, 50 to 60, 60 to 70. And we show that the model is performant across all the different decades of a woman's life, and that it's very strong in identifying those women in each decade that really need more attention. And it is just when you see that type of graph, it really just hits you. This
Mhm.
isn't about density. This isn't about age. This is about risk. And that's what we need to focus on. We have another paper we'll be presenting, and all of these are going through for paper publication as well as oral presentation at this meeting, of just comparing density versus the AI image-based risk assessment. And it's really just so powerful to see how crude density is in separating out women that need more attention from those that need less attention, and how incredibly powerful the AI image risk scores are. Because as much as density is important, it's important to know your density, it's important to know what that means. I really don't want people to be cavalier in thinking, well, I was assessed as having scattered fibroglandular density, so I don't really need to worry. Our science and our research with hundreds of thousands of women shows that you do need to worry. And just by the fact that, I mean, it's almost like we're setting ourselves up, then rather women in the future saying, how can this be? No one in my family had breast cancer. I don't want a patient to say to me, how can this be? I don't have dense breast tissue, because we've so oversold the
Mm,
density story. We really need to be more precise and more effective in educating women wisely
mhm,
about all these different domains, whether it's genetic mutations or image-based AI risk assessment or breast density.
mhm. So we have a few more minutes, so I'm going to ask these final two questions. One that I love the answer to, so I can't wait to ask you, which is that we know that the other risk assessment models were trained primarily on white women. How does Clarity Breast um, avoid, or how is Clarity Breast as inclusive as it can be in terms of taking being racially diverse in the models that it was looking at?
I love that question. So whoever asked it, thank you so much. It was so important to us that we showed equity in performance across all races and all, um, you know, areas with different geographies, and the differences that we've seen in equity based on a person's zip code or where they live, or the environmental health of the neighborhood that they're in, the diets that they have access to, etc. And so we made sure, as I referenced earlier, that we built the model with a very, very diverse data set. So the company itself, Clarity, we had well over 2 million mammograms from women all around the world. And we had different ways to learn from that database, to train, and to develop. And then the final model, that is our Clarity Breast 5-year risk model, was developed on more than 400,000 images from very diverse geographies. And then our external validation. And that's the important part, because as the FDA very, wisely said, look, it's important that you have diversity in your training model, but what we're really looking for is when you externally validate it. So not what the model has already seen, but now go out to sites where your model's never been. It's never even been at those sites. It was a very high level of rigor. And so we had these, at the end of the day, our external validation that we'll be presenting this winter is 10 geographically diverse centers from around the globe, hundreds of thousands of exams and images, and just showing that performance by race, by age, by breast density, by menopausal status. So we really show this very strong generalization, which is so important to us. I also have struggled, the more I was studying the AI image-based risk models, the more I studied the traditional risk models, which have sort of really struggled from the beginning, that they were built largely on European Caucasian women, and it's been hard to have them generalize to women who identify as Black, Asian, and Hispanic. And we just didn't want to, repeat the sins of our fathers, so to speak.
Mm-hmm. And obviously, I love that question. So there is another one here about different imaging models. So I think as a radiologist too, I would be curious to hear, do you have, are, for example, 3D mammograms or ultrasounds? I know ultrasounds, whole breast ultrasound specifically is very useful for women with dense breasts, but do you have a favorite? Is there something that you tell patients that they should be getting?
So It really depends on where you live in the world, honestly, on this perspective. The US has pretty much decided the new mammogram is a 3D tomosynthesis mammogram. About half the centers still do the 2D acquired with that 3D sweep because they think the conspicuity of the calcifications and the distortions is more easily seen on that 2D acquired. The patient experience is the same. You would have an extra click that you wouldn't notice, and that's the 2D acquired, and then the sweep, and then you have your other three views and you're done. So in the US, it's really 3D tomosynthesis mammography because all the radiologists are so used to that. I'm like, that's what you should have because that's what everyone has really adjusted to be able to read and read well, either in a combo mode, the 2D plus the 3D sweep, or just the 3D sweep with a synthetic 2D. So I think that's sort of our standard. I really see the day where we're going to leverage the value of contrast enhanced imaging at a much higher level than we're doing now. I think contrast enhanced mammography has been put the rigorous paces of research and has shown again and again and again that it has equivalent performance to MRI. It is a much less expensive modality than MRI. It is a much potentially more available because you look at the map of the country where there are mammography machines and where there are MRI machines. We have a lot more mammography machines that would give women access to the vascular-based imaging with contrast-enhanced mammography. I love ultrasound. I use it all the time. It is a great tool. It is not a great screening tool, and every study has shown that. So it gets a lot of attention because we love that ultrasound has no radiation, but I remind people that the radiation we have with a mammogram is so low and so safe. It's gotten safer and safer with every decade of use. So I'm just a huge fan of 3D mammography, contrast enhanced mammography, and ultrasound when we really need to move into the diagnostic phase of cancer detection and diagnosis.
Mhm. Is contrast something that patients should be asking for when they go in to see?
I think if they are at increased risk, they should talk to their doctor. And so at the NCCN now, and the American College of Radiology, they have started to put in these caveats that we're still recommending MRI, but if there's a reason the patient can't have an MRI or doesn't want an MRI, consider contrast enhanced mammography. There's been a lag for the science and the research and the proof to catch up to the clinical implementation that we've experienced with MRI. And I honestly think one of the biggest barriers is the payment, that the
Mhm.
centers are still not being paid for contrast and enhanced mammography at the screening level. They should be, that needs to be worked out. And I think that's then going to shift more women having access to contrast enhanced mammo.
Mhm. There's another question here about Clarity, and I know Clarity was trained on 2D mammograms. Are you also working on getting it trained on 3D mammograms?
We're working very hard. Again, as a small company, the two that we have absolutely set to be able to launch in 2026 is a multi-vendor model. So we trained and we validated on Hologic. We've already done the internal testing to show that it demonstrates equivalent performance for GE mammograms, but we need to go through the paces of the clinical validation for the FDA to have clearance to sell the product for GE mammograms. And we're very, close to doing that because of its performance. We have some more work to do on the 2D synthetic. So any woman that gets a 3D mammogram without that 2D acquired mammogram at the same time, if she only has her 2D synthetic, we want this model to be able to generalize to that. And there's a lot of methods to be able to do that. So that's also like next in line for our 2026 launch of both a multi-vendor and a 3D, 2D synthetic model that's performant on that.
And there's a final question here. I think it's a secret researcher actually, about does FES PET is FES PET useful in this work?
Useful in this work or this
I
world?
think in this, it says in this work, so I think it's talking about
Okay.
Clarity breast.
Okay, so anywhere that we have images, the power of AI and computer vision, I think has relevance. So I think absolutely, whether we're talking about FES PET or MRI or contrast enhanced mammography or ultrasound, AI has applications, and we're seeing those applications being developed and created and tested and grow. So I absolutely think that. Of course, the FES PET is more for patients with known cancers and really evaluating the extent of disease or the likelihood of response to different types of therapies.
Right. Well, I hope that set up this conversation and it's lived up to everyone's expectations, because the fact that we are on this precipice of radical change in the way that we assess risk for all patients, especially in the younger populations and in women of color who often are more vulnerable to this disease, should have blown your minds, as I predicted it would at the beginning of this conversation. So I hope that everyone leaves a lot more informed and ready to ask about this at your next doctor's appointment, so that we can encourage doctors to try to get it in their screening centers as well, right? So I thank you so much, Dr. Lehman, for joining me today and for answering all of our questions. I also, just as a reminder to everyone, BCRF, we are kicking off Breast Cancer Awareness Month at Grand Central in Vanderbilt Hall. So if you're in New York, please join us all day from 7 to 7, and we hope to see you there. There'll be a lot of fun activations and things to take home with you as well. So please visit bcrf.org/events for other upcoming webinars that we have. Our next one is on October 13th for Metastatic Breast Cancer Awareness Day, and we'll be talking about MBC. So again, thank you so much, Dr. Lehman. Do you have anything final that you wanted to say and make sure everyone knew before we hop off?
Sadia, thank you so much. This with you, the recent event with the BCRF in Long Island, and then at the end of the month, the BCRF big celebration in New York for its investigators and supporters. It's just perfect bookends to this Breast Cancer Awareness Month for me. So thanks for all you do. Thanks for everyone that joined us, and look forward to seeing you throughout the month.
Thanks, Dr. Lehman.